Yeah, hi guys. So yesterday I explained how we can resolve the data skewness by using the salty technique. Today I'm going to explain what is shuffle partition, on what scenario we need to increase the shuffle partition, and what scenario we can able to decrease the shuffle partition. Okay, what is shuffle partition? Shuffle partition is nothing but bringing the similar data into one place. Okay, and then what is the default shuffle partition in the Spark is nothing but 200. Okay, 200. So suppose we have a three executors. Okay, this is executor one, this is executor two, this is executor three. Okay. So here we have a when we read the data from the file, so it will Spark will automatically distribution the data, right? So here Kohli score 100 runs, Dhoni score 100, Sachin 50. Like that, data will be distributed. When you did the group by or joins, right? So it will do the shuffling the data. So when shuffling will happen, once shuffling will happen, right? Then all the similar data come into one place. Then only it will be group by do the count. Okay. So Kohli will be 100, Sachin will be 200, Dhoni will be 250. So like this, shuffling in a sense bringing similar data into one place. That is called shuffling. So I told by default shuffle partition is 200 in the Spark. Okay. So on what scenario? So scenario number one, how on what scenario we can able to increase the shuffle partition, on what scenario we need to decrease the shuffle partition. Okay, so we cannot did always transformation with the default partition. Based on the requirement, we need to increase or decrease the shuffle partition. Okay, so, so whenever you did the joins or group by, right, so we will able to see the shuffle right in the Spark way. Suppose you think 300 GB is the shuffle right. Okay, so we have five executor, each execute four core per executor, right? So this is the executor one, two, three, four, five. Each executor we have four cores, four core per each executor. So then total number of courses will be 20. Okay. So here, if we particularly you did something join our group, so it will taking too much of time. Okay. Then it is completed. Then we can see the shuffle rate. What is the shuffle rate of the data? So if you know the shuffle rate of the data, 3300 GB. So then we can able to know. So this much particular shuffle partition we need to give. As instead of 200, we need to increase the shuffle partition. How we can know? So shuffle rate is 300. Okay, GB. So our default is 200 MB, right? So two ones are two fives are. So 5 into 1500 MB. Okay, so by based on this calculation, so we need to give 1500 as a shuffle partition instead of 200. We need to give 1500 as a shuffle partition. Then it will execute as per the parallelism. Parallelism will be increased and task will be completed as soon as possible. So this one Spark will create 1500 parallel tasks during shuffle. So here, right? So and our Spark will divide it 300 GB of data. Whatever 300 GB of data into divide into 1500 partition. Okay. So this is called shuffle partition. Now you got it right. Shuffle partition is nothing bringing similar data into one place and then it will do the transformation. Okay, so on what scenario we need to increase the shuffle partition? Scenario, suppose here we'll get uh, 5 GB or else 10 GB. So what is the calculation? So 10 into 10 GB, so 200 default 2 ones are 2 fives are is a 50. So if you give the 50, default partition is equal to 50, then this is the enough for this particular data. So this is the way how we can calculate the shuffle partition. Suppose if your task is keep on running, taking longer time as expected. Okay, this way we can able to calculate the shuffle partition. Got it right? Understand? Okay, thank you.